I'm not going to start this off by saying okay, but okay, here we go. Okay, so the compensating elements on a 380 SL 116 engine, you can see them here, okay? These compensated elements are still deflated, mind you, meaning we took all the oil out of them at the machine shop when I had the heads redone. So right now they're going to be compressed more than they are. But what the factory specs require, I'll see if you can see this on video here with my thumb, is that there's some play on the actual compensating elements. These things move about 2 millimeter, I'd say, easy. And they can't be, they have to have some compression on them. So the valve, as it sits in the seat, has to push up. Here's the shims in the back. I'll get that over here. You see where, right back there, you can see the shim that this rocker sits in. And that shim sits inside on the top of the valve. Now these shims come in varying heights. Now the way to determine if it's the right height or not is that you have to measure how much this valve pushes against this rocker and deflects itself down to push the compensating element down. Now they can't be bottomed out and they can't be fully lifted up to the top. There has to be a set play. So what I did is I went to the 3D printer and I printed off this piece because I'm cheap and I didn't want to buy the $110 tool. And I looked online, and online there's a measurement that the actual height of the compensating element should be around about 29.67 millimeters tall. So what I've done with this is, it's not the exact same spec, but I know what we have here is, trying to do this with one hand, 45 millimeters of height. Now obviously if we have our 45 millimeters and we take away our 30, we have 15 left, duh, easy math. And that at that 15 height, that means it's at the maximum tolerance. Now it allows a 1.2 allowance, so I guess I could go from 15 down to, I don't know, 13.8. Big with the math here today. So what you can do now is that I made it with a hole in the top. So this piece will fit right over top of the compensating element. You can see everything lines up. You can see the top of the compensating element through the hole right here. Put it on, levels it off. What can we do? We can measure it. Let me just show you this. I hate working with one hand. I need to become a real YouTuber. So what is this at? Now mind you, this is not loaded. The lobe of the cam on this is all the way up. You can see it over here on the top lobe. So that's the way it's supposed to be. And then what you can do is you can see that the measurement now is going 16 millimeter. So that's within spec. Now this measurement doesn't mean anything right now because I have to crank the engine without fuel to prime those compensating elements, and what they're going to do is they're going to give some resistance to it. So the measurements are going to change, but this is how I'm going to figure out what I need. So if anybody needs this tool or the design, it just took me a couple of minutes to make. I based it off the plans, but this is going to work. So this is how we're going to measure each one of our compensating elements. And then we'll be good to go. What else can I show you? I think that's pretty much it. So we got the rails in. These clips, I did it while it was warm. These rails, they slide in. They only slide in one way. There's little holes on the bottom. You can see that. I don't know if you can see that there. You can see that little hole there will grease this journal and so on and so on. And then they have the little clips. These clips are really easy to do if you ever have to do them. They're in here snug right now. You had to hammer them in with a rubber mallet pretty good. I made sure that everything's seated. But online you can see people talking about these clips getting brittle and then them letting go. And I think it would probably only be the case if you were touching this. So the only time that you'd ever be doing this is that if you had the heads off, if you're doing something with the timing, like if you're here already, you know, they cost like $4 or something like that per side. You have to order 2 sets. and they just slide on. They only go on one way because there's a little lug eccentric inside the actual clip itself. So right now, I think we're at a really good spot. I went through the car itself. There's only a couple more things that I have to do. Here's the original valve cover. What happened? My timing chain snapped. Why did it snap? This guide, the inner guide, which is the exact same one as this one right here, let go. Caused slack in the chain, caused it to jump over. Everything's lining up perfectly when I check my timing. I got my distributor set on number 1. I have to confirm that. Don't take that verbatim just yet. But that's going to be no problem because I've marked everything all the way through. So we're at the stage where we can finally start putting the engine in, and hopefully this thing fires up. Okay, so we're going to make the compensating tool with the 3D printer, Tinkercad. So what we've done is we've copied the measurements online, and then what I'm going to do is just use the tailstock end of the caliper, the Verde caliper, to measure from this hole all the way down. I already know from online that the measurements that we have to have for the compensating elements are about just under 30 millimeters. So what I'm going to be able to do is measure from the baseline hole here all the way down, and I'll figure out what the 30 millimeters measurement has to be. This is my first drawing, so I'm just going to test this out first on the 3D printer, and we'll kind of see how this works out.